2.3, solving trig equations. Now, when we're solving something, that's saying something's equal to a number. Let's look at this. If I said solve for an equation that said y is equal to 1/2. Well, if this was my equation sine of x, at all of these locations, sine is equal to 1/2. So that, remember, goes on forever. So because of this, if you look, we have two really spots that we're looking at. One on the way up and one on the way down. So if we go back to our unit circle, these are our two angles that we would be dealing with of 1/2. If I said it's in between 0 and 2 pi. But because we are smart individuals and we know that every angle has unlimited coterminal angles because you could just keep on adding 2 pi each and every time, that's where we have to represent this angle plus n is the number of rotations that you're going to go around the circle, 2 pi. So yes, pi over 6 is an answer, but so is if I added 2 pi to that, which would be 13 pi over 6. So 13 pi over 6. And again, if I keep on adding 2 pi, all of those would be answers to this equation. Same thing with 5 pi over 6. So we already know how to find these two angles. Now it's just adding one added component to my answer. So let's look at this one first. If I'm looking at this, the first thing I need to do is move the sine of x over, and I need to move my numbers over to the other side. So I'm going to add sine of x over here. So if I'm going to add sine x, this would give me 2 sine x. And I'm going to subtract this square root of 2 over. So now I want to get this sine by itself. So now I have sine of x will be equal to negative square root 2 over 2. So since I didn't put any parameters on it now I can set up my quadrants. So all positive, sine, sad, turtles, those are both positive. That means I'm looking at these two angles right here, these two triangles. So this looks like it was rationalized because the square root is on top. So this is the same thing as square root or negative 1 over the square root of 2. So if I'm looking at my sine, that's opposite over hypotenuse, opposite over hypotenuse. So this was negative and this is negative. So when I'm looking at this, what special right triangle has a hypotenuse of square root 2 is going to be my 45, 45, 90. So if this is 45, that's, remember, pi over 4, except this angle right here, when I say that that angle is pi over 4, I have to add on this pi to it. So if I look at this angle right now, that's going to be equal to 5 pi over 4. But again, I want the answer for all of them. So because the period of sine is 2 pi, this would give us an answer of x is equal to 5 pi over 4 plus 2 times n times pi. Again, this is how many revolutions you're going to be going around. So this is one answer. Now my other answer is this one right here. I still am working with pi over 4. So again, you could think of this as either negative pi over 4, or else you can do 2 pi minus pi over 4. That's going to give us our 7 pi over 4. So that's this angle right here. And again, my period for sine is 2 pi. So this n is saying how number of times you're going around the circle. So this is basically our infinite number of answers that we have for that question. So if I look at the second one, the squared is already there. So now I'm looking at solving this for tangent because there's only one sign here. So I'm going to add over my 1, and then I'm going to divide by 3. So I'm going to have tan squared x is equal to 1 over 3. I had to get rid of that squared because we always want to try to rewrite this to sine, cosine, or tangent. So this is the square root of 1 is 1, and the square root of 3 I'm going to keep. So now this is where you have to be a little bit more careful. So when I'm looking at this, this is positive. Sorry, it should be positive and negative because when we take the square root of unknown, we have two answers. However, when we're talking about tangent, typically our tangent is going to be in between 0 and pi because that's the period for tangent. So we really only need to work with 2 of our answers. So we need to have an equation that would represent, or angle that represents a positive tan. So this would give me my positive tan, and this one would give me my negative tan, because again, tangent's period is 0 to pi. unlike sine, is 0 to 2 pi. That was 1 period. So now when I look at this, my opposite is 1, and my square root 3 is going to be my hypotenuse. So this is positive 1. So in this case, when it's created across from 1, this angle right here is pi over 6. When I'm looking over here, this angle right here, actually, because this is also will be pi over 6, so this angle in the blue would be 5 pi over 6. So this is going to take care of our positive answer and our negative answer. Now when I'm looking at this, I'm going to have x is equal to pi over 6, and x is going to be equal to 5 pi over 6. The difference between these two is this is going to be adding n pi plus n pi, because 1 period for tangent is pi. So what if I didn't have the negative part? What if I didn't have the negative part and I only had the positive? Well, I wouldn't include the second triangle because it's just from 0 to pi. Again, 0 to pi is 1 period. Looking at example 3. First thing I'm going to do is set this equal to 0, just like how we did in algebra. Whenever we're solving for something, we will first want to set it equal to 0. Now, some may say like, oh my gosh, but there's 2 trig functions there. Well, just like in algebra, we can look to see what we can factor out, and I can factor out a cotangent here, leaving me with a cosine squared x minus 2. So now these are 2 separated. These 2 are separated, so I can set both of these because of this multiplication. I can set both of these 2 equations equal to 0. So I'm going to have a cotangent x is equal to 0. I'm going to have a cosine squared minus 2 is equal to 0. So this is already by itself. We'll get back to that in a second. But now I'm going to solve this for cosine. So I'm going to have cosine squared x is equal to 2. And then I would take the square root of that. So I'm going to have cosine x is equal to the positive negative square root 2. Now, a couple of things. When you're talking about cotangent is the 0. So when we're talking about cotangent, that's our y over r, or y over x. Sorry, x over r. So when is x 0? So again, cotangent's period is in between 0 and pi. So this point right here at 0, 1, that gives us our x value at 0 because cotangent is x over y. So this right here, this angle is pi over 2. So this is x equals pi over 2. Again, 1 period of cotangent is pi, so this would be plus n pi. Over here, this is where you have to be careful. If you don't know square roots, you should take the square root of 2, and you would get that this is greater than 1. Well, this is not in my domain of cosine. Cosine should always be between negative 1 and 1. So there's going to be no solution for this one. So this right here is my only answer. Now, if you look at example 4, this one's a little bit different because I'm not going to have n in my answer. How do you know if you have n in your answer? If it does not have this parameter. So first thing here, I look to see if I can factor. So again, this is just like our x squared, x, and our number. So if I'm going to factor this with our 2 numbers and be with 2 and 1 that add together to get negative 1 in the middle. So when I'm writing this, I'm going to have a 2 sine x, and I'm going to have a sine x. Both of these, because we have to multiply to get 1, we have to decide which one should be positive, which one should be negative. So this right here should be a negative 2 because we want to add together to get that negative 1. This should be a positive 1. So now since we factor that, we set both of those 2 equations equal to 0. This one equal to 0 and this one equal to 0. And if we solve those for sine, we get these 2 answers. So if I look at my sine, well, first sine right here is always going to be our our y over our r. So where is y equal to 1? So where is our y1 would be right here. That point would give us our y at 1. So we know that that angle right there is going to be pi over 2. Okay, so now we have to create our 2 triangles for this one. So this is all set, so those are positive. So these 2 spots are where sine is negative, and this is a negative. My opposite, which is 1, and my opposite, which is 1. So in this case, when our hypotenuse is 2 and our opposite is 1, so this would be like our square root of 3, this is going to be a 30-degree angle. 30-degree angle. I'm asking for 0 to 2 pi. So in this case, this is going to be our pi over 6. So we have to add pi to that. So that would give us our 7 pi over 6 for this angle right here. And this is kind of like our negative pi over 6. So if we do 2 pi minus pi over 6, we would get are 11 pi over 6. And we only have 3 set answers for this because of this interval. And because the next section is just a little bit more difficult, we're going to split this into 2 parts. So that is 2.3 solving trig equations part 1. Come back right here for part 2. So we're going to split this up into 2 spots. This is part 1. I don't know if I already said that. Have a great, grand, wonderful day.